So without further ado, I want to introduce Greg Wilson. Dr. Greg Wilson was one of the founders of software carpentry, which is now a worldwide movement that teaches researchers and scientists how to code and really propagates the idea that like anyone can learn this. We're here to support each other. It's a very positive learning community. And now he works with Data Camp, which is again bringing knowledge to the masses, creating curriculum that help people learn new technical skills. So welcome. Sorry, I have to like put my head in here. Hello.
Thank you very much. So as Danielle said, I co-founded Software Carpentry with Brent Gorda back in the 90s. At the time, I had just wrapped up a stint as the tame programmer in a physics department at the University of Edinburgh. And over again, I saw people who were a lot smarter than me taking days or weeks to do things that I could do in minutes. And it wasn't a matter of intelligence. It was that I had been shown there was a tool. I had been shown there was a method. And they had been so busy learning their physics, learning their biology, learning their geology, that they hadn't had time to go off and hunt around and find out that there was an easier way. And we started teaching these workshops at Los Alamos in 1998. And it was an on-again, off-again thing for a few years. And then in 2010, I left a faculty position at the University of Toronto and devoted myself to this full time. Because I'd never been a particularly good researcher, but I do like the sound of my own voice, and this was a chance for me to talk more often. We wrote a paper that came out a few years ago called Best Practices in Scientific Computing. It's one of the more popular downloads from PLOS Computational Biology. And a year after it came out, I realized that it had been a mistake that I needed to fix. And I'm quite serious about this. If on your first day in the gym, somebody is telling you what Olympic athletes do, it's probably going to scare off more people than it entices. And if we start by saying, here's what the very best scientific coding teams, research coding teams do, it looks out of reach for people. So we came back and we wrote the paper Good Enough Practices in Scientific Computing, because you don't have to do everything to perfection every time. Hands up those of you who do wet lab biology. Okay, so I'm willing to bet there's some equipment in your lab that's held together with duct tape. Okay, and that's good enough for many purposes. You don't have to do everything to NASA clean room standards in order to get the right answer. And I think one of the things that's gone wrong with the push towards better scientific computing practices and reproducible research is that we're insisting that everybody do everything right all the time, right from the start. And it's not realistic and it's not helpful. As scientists, part of your training implicitly is to learn when you can cut corners, right? What is good enough? I trained as an electrical engineer, and I know that if I'm wiring up a sound card, I can just do a little bit of hand soldering and that'll be good enough. If I'm wiring up a piece of precision microelectronics, it's a completely different ballgame. And there is no hard and fast rule about when I can just throw on a splash of solder and when I have to go in there and actually weigh the solder down to the milligram level and make sure the temperature is exactly right and use all the right reagents to clean things. You pick that up through practice and then you pass it on to the people beside you, to your own students. And part of what we were fumbling towards with the Good Enough Practices paper was, where do you start? And I'll give you an example. A quick show of hands. How many of you use version control on a regular basis? Okay. How many of you use Google Docs? Okay. So 4 years ago, I repeatedly made the mistake of telling people that if you're not putting everything under version control, you're not doing real science because it's not reproducible. That was arrogant and wrong-headed. For many purposes, and in many situations, a Google Doc with a well-chosen name so that you can actually find it again is a good enough way to collaborate on writing a paper. It's the path of least resistance, and it is better than mailing around Word documents. I don't know how many of you have ever tried to reconcile 17 different senior faculty's contributions to a major grant proposal on the Thursday that the grant proposal had to be in. Right? Not the best day of my life. Right? And something like a Google Doc or an Etherpad is a step forward from that. And you don't have to incur the horrific penalties of learning user hostile tools like Git. Right? Git is probably the most difficult piece of software I've ever tried to teach people. It is needlessly complicated, written by somebody who is famously antisocial, and I'm being polite in my choice of words here. And, well, it makes it clear that the author doesn't care if 99% of the species can actually use the tool. And to then take that to people who are working as hard as they possibly can to push the frontiers of knowledge in biochemistry or molecular biology and archaeology and any of 1,000 different research disciplines, and say, here's some extra burden. I promise that on the other side of this pain, there's something worthwhile, but you've got to go through this needless pain first. What the hell? So increasingly, I'm interested not in what the best practices are, but in what's good enough. And part of what prompted this as well is that my sister-in-law is a paramedic, right? And she's actually pretty good at keeping people alive in difficult circumstances. That's her job. And she isn't by any means a cardiac surgeon working at the Mayo Clinic, but she doesn't need to be, right? And for most of the things you do, I think that measuring yourself against Hadley Wickham or Titus Brown is as pointless as me measuring myself against Usain Bolt, right? That isn't what I'm aspiring to. And if that's the standard I use, then I will always fall short and always be disappointed. And part of what I'm hoping we will see evolve over the next 10 years is some sort of consensus, domain to domain, of what is good enough. Because right now, we don't have that consensus. Right now, we don't have any expectation that different labs, even different individuals within the lab, are meeting the same standards, because we don't actually have standards. There's an old joke that physicists worry about decimal places, astronomers worry about exponents, and economists are happy if they can get the sign right. Okay? But there's a kernel of truth in that. In some fields, 6 digits of accuracy is the minimum you have to have for something to be worthy of publication. In other fields, 1 digit is good enough. Like 1 significant digit in astronomy is often good enough. And each community has evolved those sorts of standards of how long should this take? How exact does it have to be? How good is good enough? If I am TAing a first-year physics course and students are rolling marbles down an inclined plane to try to measure the value of gravity, if they actually get 9.812 meters per second squared, I know that they're lying, right? I know that that gear isn't that accurate, but that's okay. In their situation, it's not supposed to be, and it doesn't have to be. Similarly, I don't yet know what to teach you to look for when you are reviewing the code or the scripts that are used to generate the results in a paper. I think you know how to check the stats, but we don't yet have a sense of what should every biologist know, what should everybody working with medical data know, and how should their code be written so that other people can check it. You all know how to write a paper so that other people can follow the steps and check them out. That's part of your training, is you read lots of these. When you start writing them, your supervisor and your colleagues come in and say, no, you don't do it that way, you do it this way. And so you implicitly soak that up. And part of the revolution we're going through now is trying to come up with community norms for that. Best practices was our first stab at what those norms should look like. It's almost certainly wrong in every detail, but it gives us something to correct. It gives us something concrete to point at and say, no, but. And what I'd really like back from all of you over the course of tonight and the coming weeks and months is that but, is that sense of, sure, we don't do it that way, and here's what we do instead. Here's why the thing you recommended isn't appropriate for us. It's either overkill or it's not good enough. Here's where we are instead. Right? And my aspiration is that 10 years from now, when you get a paper to review, the code will come with it, the data will come with it, and you will know what to do with those, and you will have a reasonable expectation that the author is expecting you to do those things. And I'll add one more before I start going through the questions. Can I just ask the folks in Portland, how many of you did a statistics course as an undergraduate? Okay, so let me tell you a story. A lot of my stories aren't true, but this is a true story. In 1960, none of the top 20 schools in the States required undergrads in the life sciences or pre-med or psych to do statistics. And in fact, many of them didn't even offer stats at the undergrad level. By 1970, they all offered it and most of them required it. So the question is, why did it happen then? Why not the 50s or the 70s or the 40s or the 80s? What was special about that decade? And the first time I heard this question, my immediate reaction was, oh, that's when computers became available. But it turns out that's not the reason. What happened was a generation that had encountered statistics and operations research during the Second World War had aged up to the point where they were now sitting on curriculum committees. They were now signing off on grants. They were now department chairs. So you had a cohort with a shared vision of what better looked like, getting their hands on power at the same time. Okay? And this is software carpentry. Well, this may not be software carpentry's long-term plan for global domination, but sure as hell is mine. We are teaching people these skills so that 10 years from now, when you all have tenure, you are all going to get tenure, right? So 10 years from now, when you all have tenure, you'll be able to make the changes that we can't make now. There aren't enough of us now, and we're not in powerful enough positions yet. But if we keep pushing, we don't have to convince everybody. We only have to convince N+1 of the voters on a key committee on any particular day. That's how change gets done. Right? And so we run these workshops and we teach these skills so that 10 years from now, you will be able to do all the things that I wish I could do now. Okay? So let's hop into the Etherpad and take a look at the questions.
Great. Before you do that, Greg, I just want to put it up on the board because we're mirroring displays here. So let's see. So the Etherpad, help me with your computer. Yeah. How do I get to display? Oh, there it is. Yeah. So it's, if you go to this web address.
It's also in Slack.
It's also in Slack, or you can click through to our GitHub page. So it's, public.etherpad.mozilla.org/p/biodata-club-good enough. So that is where you can find it. And then you can just add your name right here. And so I'm gonna do Ted a favor. And then everything that Ted writes will be green. And that way we can see who's who. And so you can add questions here. And then when Greg signs off, we have some more discussion points down there.
Sure.
Okay, cool.
So how do you suggest to the rest of the lab to follow these good enough practices? What we have found is that you send several people from a lab to something like a software carpentry workshop at the same time so that you don't just have one person trying to roll the rock uphill. Okay. Now, Danielle, am I okay to continue?
Yeah, I'm just working on Ted's computer. I need to switch back. I'm sorry. What's the
switch back
command?
to
Just the Zoom. Sorry, I can do it.
Nope.
There we go. Hey, could you tell that I was lost?
Okay.
Okay. Sorry. So first question.
So first question is, how do you get people to adopt it? The answer is you don't try to do it on your own. The most successful implementations are where you have a group of people trying to do it at the same time. It's okay to be lost if you're lost together. Right? I'm quite serious about that. If you go all the way back to people like Miles Horton in the 1930s, if you look at things like the 4-H Club, farm extension programs, healthcare programs in rural areas, right? Sexual health awareness programs, all of these things, over and over again, what we see is that if you're trying on your own, you probably won't succeed. If there's a group of you starting off at the same time together, you can reinforce each other. So if you're trying to do this, do it lab by lab, do it team by team. Right? We've had people like Pat Schloss at Michigan bring their entire lab to a workshop and then go back and say, okay, we just learned a lot. Which one thing are we actually going to change first? Right? And that works. Right? So as with music performance, as with almost anything, pick one thing and fix it first. Okay? Recommendations for protecting API keys, passwords, etc. All of mine are stored in my password manager. Right. I don't roll your own solution to something with credentials. That is one of the few places where I will go and spend money on commercial grade software. And given everything we've heard in the last few weeks about the Equifax breach, about incident after incident, go and spend $24 and get LastPass or something like that. Right? Sharing data related to human subjects, it's an IRB question. There are best practices for anonymizing and sharing that data, and I'm not going to try to talk about them because it's not an area that I work in. There are people who have worked really long and hard on this, and I will defer to them. And this is one of those places where I really, really wish we had consensus within communities, because we don't right now. I remember the talk, must be 15 years ago, where Professor LaTanya Sweeney, who at the time was at Carnegie Mellon, managed to pull up the medical records for Colin Powell, who at the time was Secretary of State. She did this live in front of an audience to prove that if you took these 3 seemingly innocuous public data sets, you could narrow it down to the only African American with senior military experience employed by the State Department living in a certain part of Georgetown. There was one guy, right? And so, if you wanted to know about Colin Powell's prostate, there it is, right? Which is only funny until you're not the target of something like that. And if you go and take a look at, for example, Zoe Quinn's book on what it was like to be the target of all of the doxing during Gamergate, people were using exactly those same techniques in order to get her home address, right? So,
just want to add something. So if people have others, like this is like a good follow-up workshop if people are interested in it.
Yeah.
So we're also soliciting topics from people. So this is a really, people have interests like that, please speak up.
We could have like a whole session on this and try to bring in experts from our community and beyond. So
if you are interested, there is a group called Crypto Party that runs a half-day workshop on how to secure your personal digital devices, how to make sure that your phone, your personal phone, your laptop, and so forth are secure against drive-by attacks. Nobody can protect you against the NSA or Mossad, right? But they can make you safe against random trolls on the internet. And they can come in, you bring in your devices, and they will walk you through the steps. I think that if you're coming anywhere near sensitive data, ever, you should go through one of those. And there are people in the Portland area I could connect you with who could either do that or set you up with somebody who could. So Danielle, if you want to give me a shout afterwards, that would be a hands-on thing to do with this club.
Thank you.
Line 51, why when using version control are teams encouraged to use Git? Because of GitHub. Nobody likes Git except the very, very tiny minority of trolls who seem to think that if software doesn't hurt, other people might be able to use it, and then they wouldn't be special. And if I sound bitter, it's because I am. Git is an awful piece of software, but GitHub is actually a really well-designed website that added value enough that people started flocking to it, and now there's a network effect. You're on GitHub because that's where everybody else is. When Nell Veriku did a fairly informal study in the fall of 2013, she found 30 times more bioinformatics projects on GitHub than on its next nearest competitor. Right? So, why are we writing our papers in English with its rather idiosyncratic spelling and grammar? Because everybody else is writing in English. Why are we publishing in CNS? Because everybody else is publishing in CNS, right? We're stuck with GitHub until somebody builds something better. Please, God, let somebody build something better. Okay? Does software carpentry have active interest in teaching middle high school students? Nope. No, there are lots and lots of other really good organizations that are doing that. We strongly encourage people who want to volunteer with us to check them out as well. But if you try to do everything, you wind up doing nothing. Having said that, I stepped down from my position with software carpentry in January of this year, but I've continued to run instructor training events here in Toronto for people who are teaching new Canadians, women re-entering the workforce, seniors, teenagers, you name it. Right? So a lot of the techniques that we use apply equally well to other grown-up free-range learners. And I have to make that qualification and say grown-up. I actually don't know a lot about teaching children. I don't know much about teaching preteens. I have a 10-year-old, but teaching preteens is a different problem than teaching teenagers, young adults, and adults, right? There are significant cognitive and behavioral differences, and so you have to use different teaching techniques. I am going to throw a link into the Etherpad, though. It's never too late.
I want to comment that whoever said that, it's not too late. It's definitely not too late. If it's not too late, if I can do it, you can do it.
I had an 82-year-old.
Not too late.
I had an 82-year-old learning to program in Python a few weeks ago.
I taught a 65-year-old this summer in R, and he got through it. So
yeah,
you can do it.
I've just added a link on line 60. Code reviews are notoriously absent in academia. Do you consider code reviews necessary? Yes. Okay. I consider a lot of other things necessary, like, I don't know, paying postdocs and adjuncts a living wage. Right? So here's the thing. Fall of 2012, Toronto District School Board, which is the largest school board in Canada, voted unanimously to introduce programming classes in all high schools in Toronto. Right? Hasn't happened in the 5 years since, because nobody can agree on what to cut in order to free up the resources needed to do it. There was a very serious proposal to not teach math in high schools so that we could teach programming instead. As a programmer, I think that's insane. Right? There were proposals to cut second languages. Well, that's not going to fly. There was a proposal to cut gym and health in order to make room for programming. And again, as a programmer, I strongly oppose that. So if we're asking you to review the code that was used in a paper, we're asking you to put more time into reviews. Right? Even if we train you how to read the code and how to look for things that are worth finding, we're still asking for more of your time at review. What are you going to cut to make room for that? Anybody who won't tell you what's going to be cut from your schedule, from the demands on you in order to free up time so that you can read somebody else's code, isn't being honest. Okay? Hands up if you've ever been involved in a budgeting process. Okay, so that's my first rule. I've been involved in a lot of nonprofit and political organizations as well as software carpentry. My first rule is that when somebody is proposing something, you ask them, what are you going to cut? And if they won't identify something specific, if they'll wave their hands and say, oh, but I'm sure we can squeeze out some inefficiencies somewhere, or maybe we'll find a grant, then you can just dismiss them. Because if they're not willing to make the hard calls, even hard calls that you don't agree with, then they're not serious about affecting change. So the next time somebody tells you you should be reviewing code, you say, absolutely, I'd love to. Tell me what I don't do. And I'd like to go a little further on this. Hands up if you think reproducible research is a good idea. Right? Nobody's opposed to reproducible research. So let's run some numbers, shall we? I love numbers. You can make them say anything. So here's me. In the decade 1990 to 2000, 5 million credible scientific papers were published worldwide. Right? Round numbers, there were about 5 million papers published in that decade. In the 17 years since, fewer than 50 have been withdrawn because of computational errors. Some, there's been outright fraud. In some cases, the data was suspect. But the number of cases in which we know people botched the computing is small enough that we can list them all on one sheet of paper. Those are the ones that we know about. I'm sure there's lots of others out there, but I'm only talking about the ones that have been found. So that's 50 cases over 5 million papers. That means the chance that your paper is going to have to be pulled because you botched the computing is 1 in 100,000. Okay? Now let's suppose that you do one paper every 8 months, and that, like most people at your career stage, you're working a 60-hour week. Okay? Do the math and flip it over. As insurance against your paper being borked because you screwed up the computing, you should spend an extra 130 seconds a year. Right? The risk, the cost of having to pull a paper is high, but the risk is so low that the extra effort it's worth you putting in is infinitesimal. So by not doing reviews, by not producing nicely formatted R packages, you are making a rational economic decision. I hate to say that, but it explains why all of my attempts from 1998 until 2012 to scare people into adopting better practices failed. Because for 14 years, the drum I was banging was, you need to learn better computing practices, because if you don't, you might publish something you have to retract and your career is over. Right? And people didn't show up to workshops. What changed after 2012 was that we changed from a negative messaging to a positive messaging. Instead of trying to scare people into doing the right thing, we said, look, if you adopt these practices, you will be more productive. You will get more papers out. You will be able to do more and better research faster. And that was a much more effective message. It's really hard to scare people into change. As George Monbiot has pointed out in a different context, all of the research we have says that when people are scared, they become more conservative. When they're frightened, they stick to the devil they know. If we want people to adopt better computing practices, better open science practices, open data, anything and everything, we have to offer them a carrot, not threaten them with a stick. And the carrot had better be real. And until I know what to offer you as an incentive for you personally to review other people's code and to create code and share code that's worth reviewing, I don't think we're going to see much change. Okay. Okay, I am over time because I was only supposed to, I told you, I got into this business because I like the sound of my own voice. So I'll take questions from the audience before I turn you back over to Danielle and co. Any others that aren't in the Etherpad?
Any questions? I can repeat them for the mic, or you can just come up here and speak up. Has anyone ever worked in a lab that did code review? 1, 2 and a half. Two and a half.
I guess the reason I asked the question, and the reason I asked is I was in industry for years before I came to academia. And in industry, we had 13 engineers being paid full time to do basic. called system verification. And they were super important people. And the reason they did their job was because basically you couldn't sell a medical device without the government knowing that you did a code. And we have this big problem where we can't reproduce research in academia and everything feels really sloppy and there's no even interest in structuring a process to go over code. And we sort of point fingers at each other and ask, well, why can't we reproduce each other's science? I don't know if it's like an institutional thing, like should we have like code review at OHSU and they accept code and they have some sort of system requirements that we supply to verify for us, or like is there anything we can or should do from a centralized institution?
Did you hear that? The question, so he used to work in industry, and in industry there were, what did you say, like 10, 12, 15 full-time engineers basically doing code review.
Sure.
And then you come
so
to
that's a right. So,
and so
that
his question is there something we could consider at the institutional level to make code review more the standard at our institution?
Absolutely. Absolutely. Pay people to do it. No, I'm quite serious. You aren't paid to review papers right now. You aren't paid to review code. I will bet anything you want to name that the engineers you just described were being paid to do those code reviews. Okay? So hands up if you work less than a 60-hour week right now. Okay? A lot of you are working longer than that. Right? And now we're going to add another few hours a week. Not fair. Right? Not going to stick. Even with good intentions, it's not going to stick. Right? So we have to put more resources into the system. And that either means we get more resources or it means we stop doing something else. Right? Now, personally, having formatted up 3 papers for PLOS in the last 12 months, getting journals to fix their submission systems, absolutely, if they did that, it would free up enough time that I could review all of your code. I'm serious, right? The number of hours I've wasted on idiotic formatting issues, right? A colleague of mine works at Mozilla and has a long and unprintable rant about what it's like to feel like you're going back to a Soviet version of the mid-1980s, right? It's not even a good 1980s. Like, it's a bad 1980s every time that you have to format something up for publication in a major journal. And what's amazing is that things like the Pot Growers Association of Canada have a better process for getting articles in their newsletters than Nature has for getting scientific articles published. Right? I don't understand. Right?
I think code review is another topic that we could do a workshop on. We could bring a piece of code and review it and then talk about how you review it and learn some best practices. I mean, I'm looking at you. Maybe you want to lead it.
Where's Chester?
Chester's here.
Hey, Chester.
Yeah, I agree.
Okay, so I just heard him volunteer.
Oh.
Oh, I'm one of the people that's not working the 60 hours. I like my 40.
Yeah.
Sure, I'm happy now.
So code review is one of those things that we mostly don't teach in computer science departments because there aren't, I want to say there aren't rules. And what I mean is there aren't algorithms for doing it. Reviewing code is a matter of judgment and experience in the same way as reviewing music or reviewing an architectural plan. And it's one of those things you can only learn through practice and mentoring, which means that everything we can write down isn't helpful, right? Anybody who wants to learn literary criticism from a book is probably going down a fool's path. You have to work with people to learn how to read a poem, and then you can start to understand what the criticism books are trying to teach you. And I think the same is true of code review. So having somebody like Chester walk through a piece of R and say, let me tell you what I'm seeing, and doing that a few times is probably the best way to get started with this. I mean, I really wish there was a software carpentry lesson on code review, and I've tried writing one twice, and it just doesn't work. I think it has to be done live.
Yeah, well, that would be a lot of fun.
Yeah.
Thanks, Chester.
I like Friday afternoon. So it's
Okay.
perfectly fine.
Yeah.
I'd be happy to-
We could do it at a coffee place or a bar too, alternately. Cool. Anyone else have questions or comments? Otherwise, we'll let Greg go since it's already 7:30 his time. Nope.
Any questions from our dial-ins? Sam?
Oh,
Carolina?
Sam. Do you have any questions, Sam? Or Carolina? Or Sam? Other Sam?
No, I'm good, but thank you. It was nice hearing you talk.
No, but thank you very much, Greg, for your contribution.
Great discussion. Thank you.
Okay.
All right.
Thank you all very much. It's been a pleasure.